You have been told that your IBD is just a genetic issue. It's your genes, but that's a lie. It is not a genetic issue. See, I'm going to show you the truth behind why your genetics have been blamed and why they shouldn't be. I'm going to be showing you what genetic expression is and why it may actually be expressing poorly, leading to your inflammation. I want to also show you the factors that actually influence your genes and of course how you can use this information to find the root cause of your IBD and begin reversing it. Contrary to what your doctors told you, Crohn's and colitis are reversible. Now, I've helped hundreds of people reverse their bowel disease, and I'm here to help you do it too, because inflammation always has a root cause. We just have to find it. This is the Reversing Crohn's and Colitis Naturally podcast. Now, I do these live trainings in my Facebook group every single week and put the audios here for you to listen to. If you want to watch the video versions of these episodes, just click the link in the show notes to get access to our Facebook group and YouTube channel. And for weekly updates, information, tips, and tricks, you can sign up for our email list by clicking the link in the show notes below. Now, if you don't know me, my name is Josh Deck. I'm an IBD specialist, medical lecturer, and physician's consultant. And today we are talking about why your genetics are not to blame for your Crohn's and colitis. Let me know in the comments if you've been blamed or your genetics have been blamed by your doctor for your condition. Let me know. Just type genes down below. If they gave you a reason, if there's a family history, let me know. We're going to get into this together. I want to start with what genes actually are. Okay. First things first, this little structure here is called your DNA. It stands for deoxyribonucleic acid. This is the molecule that stores instructions for building and running your body. If you think of it like a cookbook on all the recipes you need to run a kitchen in a restaurant, that's your DNA. Now, genes are going to be specific sections of that DNA. If you think of that like a specific recipe in the recipe book, each gene or a section of that DNA contains specific sets of instructions to make proteins or hormones or enzymes, again, like individual recipes out of this big cookbook called your DNA. They build those tissues, those enzymes, those hormones, and even parts of your immune system. And this is the meal that you actually eat. So if you think about your DNA as the cookbook, your genes are the recipes, and what those genes produce, that's what we're going to call it the food you actually eat. That's the byproduct of it. That's sort of the breakdown from DNA to genes to production. Now, you have approximately 20,000 different genes. Some numbers say higher or lower, but about 20,000 genes inside of your DNA. But only 1 to 2% of your DNA is actually genes. The rest is called, quote, junk DNA. Now, it obviously isn't junk. It does a lot of things. I don't believe God wastes his time spending, or doesn't waste his time creating anything that's not useful or helpful. We just call it junk DNA because we didn't know what to do with it at the time. But some of the reasons we discovered only now is that there is structural support amongst that DNA. It aids in gene regulation, all this extra stuff. It helps turn these genes up and down, or the common term is on and off, but it really is up and down like a dimmer switch. And so they call it junk DNA, but it's really not. It does a lot of cool stuff, and I just believe we don't know enough yet. But here's what's interesting. Out of these 20,000 different genes that you have, they can make over 100,000 different proteins. It's kind of like taking the recipe, right? Your DNA is a cookbook, the genes are the recipe, and then the food is what's produced. It's like taking that recipe and remixing it 100,000 different ways to get 100,000 different outcomes out of these genes. It's pretty kind of amazing when you think about it. And so here's the thing. Your genes are not wrong. Your genes are wonderful and perfect and incredible at the root of how they're designed and how they operate. It's something that we don't have technology to replicate it yet. We can edit this through CRISPR technology, but we don't have the technology to make genetics. It's really amazing what they can actually do. They're perfectly designed. However, your genes can get screwed up. The inputs that we give these genes can screw up, right? You can write an entire cookbook and create a recipe and put typos in there. Or you can have a perfectly written cookbook and tear a bunch of pages out or scribble out some sentences so they're redacted, and then the end result of that recipe is not what it should be. And so your genes can get screwed up by external things. And so I brought out a couple of genes here. You may have seen this text on the left side of my board talking about, these are different genes, the 5 most common ones that are often studied or implicated in both Crohn's and colitis. So over here, we have your NOD2. This one is also, I should put in brackets, it's also called the card 15. But this NOD2 gene, okay? We also have your IL-23Rs, your IRGMs, HLA, a specific type called DRB1, and then your STAT3. This means nothing yet, but I'm going to get there. So these are the 5 most common genes. There's typically 10 or 12 that are implicated, but these are the 5 most common. Now, here's what we have to understand. These genes have a specific task. You have a recipe in the recipe book. The recipe is designed to create a filet mignon, or it's designed to create a beef tenderloin, or I eat a lot of beef. There's a beef Wellington, beef something, okay? This is what it's designed to create. But once you screw up that input, the recipe, the output becomes screwed up. This NOD2 gene, this is most commonly seen in Crohn's, but this one actually detects bacterial components. So it figures out and detects, okay, where is this a bad guy? Is this a good guy? Is this a fragment of a bacteria that's maybe been broken down? And what it does is it activates inflammatory pathways, in this case, NF-kappa B, and it says, hey, now activate this inflammatory pathway. Found a bad guy, turn it on, go become inflamed. Imagine what happens if you have a screwed up recipe because something screwed it up. We're going to talk about what those somethings are. But if something screwed up this NOD2, it says, hey, detect bacteria, the components, the pieces, and I want you to inflame to react to get rid of it. If this gene gets screwed up on its expression, what happens? You overreact, you overinflame, and suddenly you have this crazy hyperreactive inflammatory response. You go, oh, it's just your genes. No, it's not. Your gene knows what it's doing, but something screwed up its orders, and now it's overreactive. On the other hand, this IL-23R, again, another very common one, it's associated both Crohn's and colitis. It regulates certain immune pathways like Th17 and interleukin, we call it IL-23. These are inflammatory pathways. Well, these pathways can be responsible for a lot of those neutrophil, like Th17, neutrophil response. What are neutrophils? They produce calprotectin. What's commonly hyperactive in Crohn's and colitis? This particular pathway leading to elevated calprotectin levels your doctor keeps testing. So if this gene is expressing poorly, you're getting a hyperactive neutrophil or white blood cell response. It leads to elevated levels of calprotectin. Suddenly you're inflamed, or you're hyperinflamed, or something is turning this expression up. And again, that feedback loop just keeps going and going and going until you develop, through this pathway, strictures, fistulas, ulcerations, thickening of the lining, or leading to scarring even, because these are hyperactive. Let's look at IRGM. This one again, specific to Crohn's. But this one's involved, you guys might know the term, called autophagy. This is where your cells take the old guys or the bad guys or the dead guys and they recycle them, break them down and say, okay, here's all these parts, components, we're going to use them for something else. Or we're going to use them as fuel. Or we're going to rebuild them into other cells. This is autophagy. Now this IRGM has a role in regulating autophagy and what's called intracellular pathogen clearance. So if you have a toxin or a bad guy inside of one of your cells wreaking havoc, what does this gene do? It goes in and says, hey, let's get you out of the cell, out of the body so our cells can be healthy. But if this gene is regulating poorly or it's overreactive, it might just go after and kill the entire cell, right? It might not do its job at all, leaving toxins inside the cells, leaving you inflamed. So again, these genes aren't to blame, it's how they're expressed. This HLA gene, mostly again, it's huge in colitis, we see this one, but it's got a role, a big role in antigen presentation in adaptive immunity. So basically, this is when it takes a presentation, I'm just gonna put antigen. So what it does is it takes something and says, hey, I think this is a bad guy. Caught him in the act, and it takes it to your immune system and says, you should do something about this. Get rid of him. He's a bad guy. You should react. Or next time he comes in, you should identify this as the bad guy. Not us. It separates you versus the foreign invaders. This gene regulates that. It takes the antigen and goes to the body and says, this is a good guy, this is a bad guy, or this is us and this is them. Here's the difference. Be careful now. If this gene expression is screwed up due to an external factor we're about to talk about, what do you think happens? It gets confused on what's self versus what's foreign. It can get confused about how to react to certain pathogens that are coming into the body. The last one we're going to talk about, just the fifth type, is called STAT3. This one here, again, big in Crohn's and colitis, it transmits signals for cytokine responses. You may have heard that word cytokine. These are inflammatory. So there's two particular pathways that we see. Again, if you guys like science, we're going to call them interleukin or IL-6 and 23. And these interleukins are inflammatory. And when STAT3 is transmitting a signal saying, hey, you guys should come in now and react. Because inflammation is a healing response. It's there to help you. But if this healing response is all screwed up or it's hyperreactive, what do you think happens? You are hyperinflamed. Your responses are over-dramatized. Your outcomes are a severe chronic inflammatory condition. So we're not blaming your genes. We see what they do. Your genes have a job. They are very capable of doing that job until something screws them up. Again, they don't work on their own. It's not really an on or off switch. They really work more like a volume knob. So the question is, if you have this volume knob from good to bad, what is taking the dial from one end to the other, causing those genes to express poorly? If we can identify that, then the genes do not express poorly. They identify the pathogens properly. They regulate inflammatory pathways properly, and they get your body back to a healing response. So genes are turning up or down. What is turning them up or down? This is the most important question. Now, if you've been a long time listener, you've been watching these for a long time now, you'll know I talk about 3 reasons we get sick. And I'm going to break these down in a bit more detail on how they regulate your genes. But there's 3 reasons human beings get sick. Pretty well ever. The first one is going to be a toxin. Now, toxins can be anything from chronic stress to chronically high blood sugar can be toxic. Toxins can be mold, heavy metals, and pesticides, environmental stuff. They can be alcohol, sugar, preservatives, pesticides, any kind of chemical emulsifier that's in artificial foods. All these things can be toxic to your body. So toxins are a big influencer. The next we have is going to be deficiencies. So deficiencies are basic things: sunlight, vitamin, minerals, amino acids, electrolytes, fresh air, exercise. Basic things we need for our body to thrive. If we're deficient, your genes express poorly. And of course, the last one being microbes. Now, microbes, parasites, bacteria, fungi, viruses, these create inflammatory responses or produce byproducts which are again toxic to your body, which contribute to poor gene expression. So let's talk about toxins. We have all kinds of environmental toxins impairing things like methylation. That is the breakdown or the use or utilizing raw materials into usable materials. It's that conversion process. So if we have impaired methylation or histone modification, you think, if I draw that gene and go back to the beginning, right? I drew this DNA coil, it's called the double helix. And what histone modification is how tightly coiled these things are going to be, how tightly wrapped your genes are in this double helix process. Other toxins that we tend to be exposed to, mold, pesticides, they disrupt your gut barrier and they disrupt immune function, leading to, again, poor gene expression. If we have microbes, we have a big condition we call dysbiosis. This is one big umbrella term that means imbalanced gut bacteria. When we have imbalance of microbes, remember I said they produce toxins? We call these LPS. It stands for lipopolysaccharide. Another term is endotoxins, but for our purpose, we're going to call them LPS. Very simple. So these microbes, especially the overgrowth, these bad guys, produce a lot of LPS. LPS is inflammatory, and it sends danger signals to those genes we talked about, that IL-23R or that NOD2. It sends inflammatory signals. It says, hey guys, let's up-ramp you. The NOD2, remember, detects bacterial components. The IL-23R regulates that Th17, that white blood cell response that produces all that calprotectin, leads to ulcers and fistulas and strictures and all these things. So you have these bacterial overgrowths, which create these toxins, which trigger these genes to hyperreact. We have a loss of good bacteria as well in dysbiosis. Good bacteria produces things like butyrate, which again, normally downregulates inflammation and actually helps regulate your genes, turning that volume knob up or down. We want them nice and chill. So we have all these inflammatory things now being produced. Well, the next one, let's talk about deficiencies. There's a whole study called nutrigenomics, which is how nutrition or nutrients actually influence your genes, again, to express for better or for worse. And so we look at deficiencies of vitamin D, B12, omegas, folate or vitamin B9, not folic acid, that's a no-go, but folate, zinc. These things will impair gene methylation, which is again that expression of the on or off or the up down of your genes. It will impair antioxidant defense. It'll impair your immune regulation. So how reactive or hyperreactive or underreactive your responses are in your immune system on those gut barrier, mucosal levels or otherwise. There are other things now. I put them under the toxin category. We're going to put trauma and stress. I put these under the toxin category for a reason because chronic stress is highly inflammatory, again, can become toxic in a hyperdose. So we're going to put trauma, stress under that category because, well, my trifecta looks a lot prettier than a square. And so here's what we look at. Trauma and stress can also upregulate or downregulate your genes. It can impair them. We also have something called epigenetics. Epigenetics are what's passed on through genes, gene markers in this double helix, right? Remember, this is the whole cookbook. There's one little chapter. Maybe it's a typo. Maybe it's a sentence fragment. Maybe the picture is wrong on what the meal should look like. And that can be passed down. So your parents might have stress or trauma or something which changes the coding of their genes, which they can then pass on to you. Now, it doesn't mean you're guaranteed to get a disease. It just means maybe that's your weak link. When that chain gets pulled under a load of toxins, microbes, deficiencies of some kind, that chain gets pulled and then you express poorly. You're more prone to expressing that way because of what's been passed down. That's a very real thing. In fact, there's a really neat study that was done on mice. So what they had done is they took mice and they put them into a cage, and the bottom of the cage had an electrical field so they could turn it on, zap the mice, and turn it off. Well, every time that they blew the smell of cherry blossom through the cage, they would shock the mice. And after a couple of rounds of this, the mice, as soon as they would smell cherry blossom, would become stressed. It was electrical shock-induced PTSD. They had a stress response to the smell of cherry blossom. And then what they found is as these mice had babies and grandbabies, even the grandbabies to the great-grandbabies of these mice, 4 generations, having never smelled or having never been shocked, every time they would smell cherry blossom, they would elicit a panic response. And so that stress response, that trauma, was actually genetically passed down through what's called epigenetics, the little changes in the recipe book. And so they responded poorly, having never actually experienced it themselves. And we got generations of that shit stacked on top of us with wars and all kinds of nonsense. So it's a wild world out there. But here's ultimately what we want to look at. We've gone through this whole process to say, look, your genes aren't to blame, right? Your genes are just being expressed poorly. It's like a kid in a classroom. It's not the kid's fault he's bouncing off the walls. It's mom's fault and dad's fault and the school's fault for feeding them junk food and gummy candies and sugar and food dye, which is making them go nuts. The kids are fine. They're in an environment that sucks. They hate it. They're being fed shit they don't like, and they're being forced to do things that they hate. Of course they're going to be acting all over the place. What do? We medicate them. What do we do in the case of genes? We're giving them shit they don't need, which produces microbes we don't want, which leads to deficiencies we never should have had. And so in these cases, we have to clean up our environment, our inputs and our outputs, which gives our genes proper regulation. And so in this case, what makes good gene expression? Well, let's go back to our toxins, our microbes, and our deficiencies. Toxins, primarily, it's going to be environmental or ingested. This is going to be clean food, clean water, clean air. It's going to be things like earthing, which is literally the act of putting your feet on the earth and just touching it. And we see how it actually changes genetic expression, oxygenation, inflammation. It spreads your blood cells apart so you get more oxygen through. Sunlight actually gets deep to the mitochondria, which is super beneficial. If you're like, I don't want to go into the sun, I get burned very easy. Green area with shade over top. The infrared still bounces off the green. It's really beneficial for you. That's your biggest source of vitamin D is coming from the sun. Like, I'm pale. I don't know if you guys can see this. I'm a pretty pasty dude, right? Like, if I didn't have tattoos, you'd see all my veins. I'm like translucent. So if I go out to the sun and expose my pasty skin to the sunshine, I'm going to produce probably 30,000 IUs of vitamin D in like 20, 30 minutes. Whereas a friend of mine who's from Nigeria, very dark black skin, he might produce 5 or 8,000. Because again, from that climate, he's exposed to more from home. He'd be exposed to more sunlight than I would be here in, say, Calgary, or you might be in the UK. And so your skin also correlates to the vitamins you might bring in your environment. So your environment can become toxic to you. If you get a black man and put him into the UK, one of the lowest sunspots in the world, he's going to have even less vitamin D and almost certainly should be supplementing because his skin is blocking out more than what somebody who's pale white might have. So your environment can become toxic. If you're in an environment where maybe there's damage in the home and it's very moldy, those toxins are screwing up your bacteria and creating deficiencies in your body. Water. Looking at water filtration systems. City water full of pesticides and hormones and chemicals and microplastics and forever chemicals and all kinds of junk. We have to remove these toxins from your system because they're screwing up your microbiome. Once that microbiome can heal and become healthy because the environment for it living inside, not only externally, like living near a golf course covered in glyphosate or a stressful environment, but internal, inside of your gut, when those microbes are finally coming to a place where they're balanced and no longer in dysbiosis, but they're healthy, then they produce good things. They actually help regulate the immune system and genetic expression in the right way because you don't have dysbiosis. When you're giving your body the nutrients that it needs, again, nutrigenomics, a study of nutrients and genes, they can express properly. Processing stress, trauma, emotions, going through that deep-seated stuff that will change, remember, that coding on your genes. You have this whole big recipe book as your DNA. You have this little recipe as your genes. And inside there's a little bit of text in there that might be coded poorly because of stress and trauma you're holding on to. Did you know there's some interesting research showing, and Dr. Bruce Lipton and Joe Dispenza talk about this stuff all the time, when you process stress and trauma and emotions and engage in a proper healthy mindset, it actually can rewire these genes and takes this typo in the recipe and it corrects it. And that way now when you have children as well, they get the proper recipe book handed down to them without the typos. Those can change and you have the power to do that. And it's really quite amazing. Here's what you got to know. It is not your genes. Your doctor is blaming them and that is a bloody cop-out. That is not the way. Your genes don't cause disease. They just turn up or turn down to express poorly, which leads to disease manifestation. We're going to get to questions here in just a moment. If you're looking for help, and again, for the first time in your life, like, man, this makes sense to me. It's been months, years, or decades, and my doctor's not giving me any answers. And finally, there's hope on the horizon. If you're watching on YouTube or listening on the podcast, just click the links below this episode in the show notes there, and you're going to be able to get access to me and my team, schedule a call, or send me an email with a question. We'll make sure we get you some help. Let's turn over to our questions on Facebook and Instagram. At the start of my daughter's testing, ANA was 1 to 640. IL2 was negative, HLA-B27. Can you tell me the relevance of these? So specific, here's the thing. There are so many different haplotypes and different types again, like recipes. Remember we talked about those 100,000 different expressions? You get 20,000 different genes, 100,000 different proteins they're going to create. You get all these different types. So the genes we're talking about here, they work a lot of the same way. There's just specific haplotypes that are going to do slightly different things. But again, they detect these genes and say, oh, you have this gene type. You have that number, recipe number 363 out of 100,000. That's the problem. Again, what caused it to create or express this way? So the relevance is little, but when it comes down to things like mold, or it comes down, like HLA gene, hugely implicated in mold toxicity, as well as CIRS. And CIRS is CIRS, that stands for chronic inflammatory response syndrome, and the HLA gene is strongly linked to it, if not 100% of the time. So there's a lot more to genes than meets the eye, but it comes down to the very fact that your genes don't express poorly unless given the tools to do so, or something screws up the recipe. Are we all clear on Instagram? Perfect. I either did a great job, you guys are bored as all shit. So wonderful to have you here. Thanks so much for coming, guys. We're going to see you on the next one. One of my favorite things to hear as an IBD specialist is something along the lines of, I learned more from you in 15 minutes than from my doctor in 15 years. And if this for the first time is really starting to click and it's starting to make sense and you're going, wait a minute, this might be reversible. I think there's more that I can do. This condition came out of nowhere. It happened to me out of the blue. I was healthy for 10, 20, 30, 40 years and suddenly I wasn't, and you're telling me there's no cause. If you're understanding finally that there is a cause, that something is driving this, I want to invite you to check the link in the show notes below. Send me an email, ask a question, see if a program is the right fit for you, because I promise you, this doesn't have to be a lifelong sentence. You're not doomed to this, and IBD can be reversed.